Good morning, Mark.
Hey, good morning. How are you? Or good evening for you.
Yes, a bit later here.
Hi, everyone.
Hi, Ty.
Hi.
Itai, are we recording these meetings and storing them in with links somewhere?
Yes, we are recording it. Actually, yes, and I started posting it in our wiki page, and the last 3 meetings I haven't done it yet, so I'll do that this week.
Okay, thank you.
So you'll have also the transcription of each meeting and also the recording.
Okay, great. It's because on Wednesday I travel quite a lot on Wednesday, so it's not easy to join every day.
Okay. So today, as I understand, also Durgesh, Rob, and Anu are not able to join. So looks like it's just us. So first, I wanted to show that. So let me share my screen, and I'll show a few stuff, and maybe we'll have a short meeting today. Unless you want to raise something.
No, go ahead.
Discuss something, Gilberto?
No, from my side, just go ahead, Itai. We have, yeah, I started in the background some stuff about optimization that I would like to see, guys, if you want me to progress on that, or but if we need more people, we can discuss that another week.
So, actually, so maybe you can show it and if it's ready, or
sure. I let me show you what I have thought, but and then you guys tell me if. Let me see if I can send my screen. So I just have written down some ideas, okay, in terms of what we could be talking about in terms of performance optimization. So I wrote some stuff about the objective, and I understand the objective is understand performance trade-offs when designing a system-on-chip architecture. And I am guessing that we need to analyze this in different phases. Okay? One is when you're doing the design, there is another phase when you're debugging it, and then there is a phase when you're optimizing it. And that requires different things for each of that. Okay? And then in terms of what will be the outcomes that we will get is information, some of it is RAS information, reliability and serviceability of the design. It might be a reference chiplet modeling and a reference profiling. So when we are looking about different designs, these are ideas of what is the outcome, what are we going to generate? And these are thoughts I have at the moment. And in terms of what we analyze or what we understand for optimization, there are different parameters. We can be looking to optimize power, throughput, latency, utilization. And then what things will drive that would be things like cache coherency, arithmetic intensity, cache sizes, memory bandwidth, input output, and then what will be the methodology. And there I am thinking, okay, what are the parameters that we need to define? Is a memory bound algorithm, is a compute bound, is a mix of that. So there will be different use cases, and each of those will be driven by different requirements in terms of the use cases. and then we need
Okay.
simulation tools and debugging tools, profilers. So that's kind of a brainstorm I did a few weeks ago, like in 15 minutes, trying to write down the thing that came to my mind in terms of what we could consider. It will be good for you guys to tell me, yeah, this makes sense or not. If it makes sense, start writing in a template. I am happy to start writing and put it in a public place, and then we can work together in this.
Okay. So these are it's a general it's a general concepts of optimization. So what is specific for chiplets here? What is the
Well, this is generic, but I will imagine that all of this concept applies to chiplets. And this is the way I am thinking is I am integrating multiple chiplets. And the way I am thinking about this, I had to make different trade-offs of which chiplets to select depending on the use case and my objective. That's the way I'm thinking. Depending on the workloads, I will want to optimize for power or performance, and I will need to make different trade-offs of cut sizes and bandwidth I put in the interfaces, etc., etc. So, and then I will need to validate that my assumptions are correct. So there will be a phase that I am designing it. Okay, these are my requirements. Then I will be debugging it, and then I will be optimizing it. And each of these phases will require different tools and methodology. Now, what I want to calibrate with you guys is this can be obviously to extent, okay? So you guys might say, no, this is too broad, let's focus in this particular use case only, let's focus in these phases only, and that's what I wanted to validate with you guys, so because this can become too big.
I see.
Does it make sense, Itai, or?
So yeah, so firstly,
had
yeah, and so it's
Itai, go
better
ahead.
to Hi,
Yeah.
Mona Lisa. Hi. So I think it's yeah, so first, yeah, it's better to discuss it in a also a larger forum. But I think that we need to focus maybe to narrow it down a little bit to be to discuss chiplets to be more specific for chiplets.
So did you
So-
mean narrow or expand? Because, when you, in the
narrow.
objective, I say system on chip, there is, for the longest time, I started my career in the 90s and there were many different types of chips. And over time, all of those functionality got integrated into an SoC. But right now there is the disaggregation trend, which is why we are talking about chiplets. So
Yes.
from my perspective, I was thinking more of broadening the scope in the sense that, for example, in the data center, you have the primary computing chip, whatever it is. It could be, CPU, GPU, and some custom accelerator. And then there are all the other things which are, we have a lot of discussion around, of course, the memory part is there. Then you have the photonics, photonics integrated into chip, then different kinds of elements which can be qualified or categorized as chiplet. So I think when we think of a system which is formed of chiplets, I think the idea is completely different. So when I see things like power, I'm thinking of system level power, not just the SoC power performance per se, but also when you do the communication between chiplets and all of those coming together. So that's how I was thinking of this, instead of just the main SoC or the accelerator or whatever it is. So that's where I was coming from. So today we have a few people missing actually. So
Yes.
I was thinking more on that level. When you look at
Yes.
when they put up this 50-pound like a integrated computer in front of you, all of so many different components are coming into play. And right now we have the HBM as the memory chiplet, but there's so much talk about photonics and the other types of chiplets that can come into play in the data center. I was thinking like that. So
I see.
so go ahead. Yeah,
Okay,
please.
okay, so I'm okay. In my opinion, it's yeah, I thought of yeah, the opposite of narrow it down, but for example, from what you said, so power for example, so I agree it should be the power of chip of the power optimization of a chiplet power, not just an SoC power, because this is
That's right.
a whole big topic. But here we
Yes.
are specifically want to discuss the power optimization of a chiplet or several chiplets in a package.
That's
So
right. That's right. So it's system
that's
level
what I'm.
power.
So yes, but
System
yes,
level
but
power,
with the
right? Yeah.
yeah, but with the notation or with the intent to address chiplets. That's what I. So when we discuss power, okay, we want to discuss the power within a package that holds several chiplets.
Okay.
That's
Okay.
what
Yeah.
I want.
Sure.
So I agree with you on certain things, but what my opinion is that it should be more dedicated to chiplets. For example, the power is a good example.
Right. It's not only the power optimization at because in my
by the way,
practical experience, yeah, go ahead.
Gilberto talked about the different subject. He talked about the performance optimization, not the. So we have another subject which is in your plate, which is the power efficiency, right? But I think Gilberto, you are talking about the subject of performance optimization.
Yeah, the subject I am a contributor because we don't have a lead is the performance optimization. That's correct. Now, within the performance optimization, you can take into account you might have different performance target depending on the power consumption. So that there is some relation there depending how you play with that.
But you had four metrics, right?
Keep in mind that there is another subject which related only to power efficiency.
Yes, and this is where the way I was thinking about this, Itai, is, and this is an internal discussion we have as well in our organization for a similar use cases. Depending on the workload, I can tailor my power to achieve certain performance, or I can reduce the power consumption in certain use cases because there is low utilization and stuff like that. So that's the way I was thinking about it. Okay, let's assume I have a limitation in memory bandwidth, so my main core can run slower. So how I do detect it and how I use it, that's the way I was thinking. Okay. So now I say system on chip. In reality, I wanted to say system on package. Apologies for that. But now you're making a good point that there are things that are inside the chiplet, and that's kind of we need to focus probably more in the compatibility across chiplets. Assuming a chiplet is tested in isolation, is more the integration of chiplets. That should be the focus, I'm guessing.
Yes, absolutely.
You're right in the sense of we need to understand the power consumption on the interface, but I think that also if two chiplets are working at the same time and there is a power limitation in the package, okay, you might need to have some information at the package level where you say, okay, one part is too hot, the other one is not, so I need to balance my power and performance in a different way at some point.
That's right. Absolutely. So it's more of thinking when this is we are talking about chiplet marketplace, right? So trying to come up with some kind of sort of guidelines as to if there is say a photonic chip supplier, who wants to play in that ecosystem, what are the guidelines we are going to give? So I was just stepping back and looking at it more in terms of what should be the system level optimization coming from various chiplets which are integrated to make that system. That's what I thought was the intent of this. But So I think, I mean, we have to think in those lines. Of course, each component has to be optimized in a certain way, but when they come together is when they break down. They don't, the compatibility issue is not just the interoperability, but in terms of, can the system tolerate that kind of a power performance when all those chiplets, which we haven't encountered earlier, when they come together, will they work or not? So I was thinking, stepping back and thinking that way.
Yes. So you are talking about your subject, the power efficiency, right?
No, it's not my subject. I'm talking
It's-
about this forum in the sense that it could be, the output of this work group should be something of that nature. I mean, I
Yes,
put
I think.
I put power because there was no owner, but that's not really my subject.
Okay.
It's more like I
No,
want to
okay.
make sure that the entire system works.
So I will say it in maybe another different words, but maybe it's the same intention.
Sure.
So now I'm looking. Okay, I'm trying now. I'm developing a chiplet. So my question is, what should I do in terms of power in order for my chiplet to work with other chiplets? What are the parameters I should provide for the system on package, and what are the requirements I should develop accordingly, so it be able to coexist with other chiplets. So that's that's how I see it. So this is
I think we are saying the same thing.
Okay.
Yeah. Coexist is a good way, and it's almost like the rest of the system will be a black box to that particular chiplet vendor, and different, say, vendor A, B, C come in, and they have to meet certain objective, and then the system will perform the best. That's the goal.
So
Yeah.
So we need for example, we need a list of parameter, like, I don't know, leakage power, full, I don't know, maybe full maximum power, average power, something like that. When I develop a chiplet, this is the parameters I should provide for the system, and that's how the if someone else is developing the package with and selecting chiplets, that's the parameters he would like to know and decide accordingly. So I think that's
right. That's the goal.
Yes.
That's the goal.
Okay.
So Itai and Lisa, in terms of turning this back a little bit into the performance or not just the power, I think Itai, you were making good comments there. I guess if I turn it around with the performance focus, is the same thing. Is I have a chiplet, the performance of that chiplet will depend on how it's integrated with the rest of the chiplets in the system.
Yes, it's a yes.
So it will depend on the cache coherency or no coherency with other chiplets in the system, interconnect with other memories. Several things are parameters that will affect the performance of the chiplet in the system. That's kind of the way I was thinking, basically.
Yes, you know what? Exactly. So I agree. So this is the list of parameters that when I develop a chiplet, I need to advertise on my chiplet in order for other chiplet or the system designer that designs the package and selects the chiplets, that he needs to know in order to make sure that the outcome is good for him. Yes.
Yeah.
Okay.
All right.
So according to that, I think you can proceed.
So one comment then forwarding on this, then Itai, there is, in terms of we are agreed that we are trying to understand this performance now. we will need to define different things, and this is what I was going in terms of different phases of the design process and manufacturing. For me, there will be one phase that is kind of high-level modeling on design phase when you are trying to work out what is the best architecture. There will be another phase in which you can have made your choice and you're actually verifying or debugging it, depending if you're simulating or it's actually you have the physical chip. So there will be one phase that you need to debug it. And we can keep it this as one thing for now. But if it is in silicon, I will imagine that we will need to define parameters or signals or something that enable to analyze what is going on.
Yes. There was in a few weeks ago in the Friday meetings suggestion made by Raghu Shankar.
Yeah.
I'm not sure. So he's suggesting a new topic, which is like a virtual prototyping of a chiplet.
Yes. Yeah.
So actually, this is something that he suggested as a topic. I'm not sure at the moment if it should be a different activity or we are discussing with him. Maybe it should be part of our activity, but this is also a full subject that he suggested. You know, virtual prototyping for chiplets. So that's I think that's what you are referring to, right?
It is one part. I am guessing that at least in the first phase, what we can do together is understanding the requirements of those different phases. The prototyping will be in the design phase, and that will be how you do that prototyping. But even when you go to production, you will need to have a similar environment. So it will have different requirements. So yes, the emulation environment will be one of the components of one of the needs for this to be successful. What we might be able to specify here is what do we need to simulate there.
Okay.
Okay, I think it's good feedback. I am happy. Next week will be difficult for me because I'll be traveling at the time of the meeting, but maybe the week after we can retake the discussion and I can present again when we have a bigger forum.
Okay, so you're saying not in the next week, but on the
next week I am flying halfway through this meeting. I'll be at the airport, so it will be very difficult for me.
Okay. So
in
on
2
the
weeks' time, I should be able to get back there.
Okay, so we can schedule on the 25th of June that you will present your initial work for the performance.
Yes, I am happy to do that. I will evolve a little bit this document that we're describing now based on your feedback.
Okay. Okay, great. And Mona Lisa, do you want also? Can you think of something that you can provide some initial document, or so we'll start progressing with the power definition? Mona Lisa?
Oh, I've been talking when on mute.
Yes.
No, I was just saying that David Rajko, I need to work with him and he's not on call. I think initially there was this, that's why I wanted the clarity in terms of whether we're just talking about the SOC or more at the system level. And I mean, based on we don't have everyone on the call today to know what the thoughts are. But conceptually, I can try to describe that and just see that we are progressing in the right direction, because I come from an, you know, I don't do the engineering work anymore, but more in terms of the product management. And my experience, at Tesla, when we were, that was the Rev 0, Rev 1 of the Dojo supercomputer. It's more of system level power. You have to look at minor, very things that are sort of usually out of the scope of, chip design, in terms of like the packaging, the material, signal integrity, power delivery networks. So I'm not an expert in that, but because I was the product manager with, putting the system together, I know of the challenges that come in putting a chiplet-based system in place. So that's the thing. I don't know and I don't even know if on the OCP team we have folks who are experts in, say, power delivery to the system. And also, yeah.
So David is he's someone that can help, or not really?
He can, in terms of, he is authoring some work on like the assembly, design kit, for example. You have to assemble this disparate, say, components, chiplets, onto a package, right? So that is also a spec. So he's doing from that part. But in terms of, I'm not sure whether he's doing any work on signal integrity and power integrity, for example, which are so intimately dependent on what package you pick, So when we have a recommendation, it will be like the packaging has this kind of features, for example. Whether it is a glass package or organic substrates, whatever, everything changes the moment you change the package. So that's why I was saying that I'm stepping back and thinking in a much, holistic, broader picture, because of what is happening in our adjacent industry, which is the advanced packaging industry. So honestly speaking, I do need to spend time. David and I are in the same boat. Our kids just graduated high school. And so he's making some travels, to Europe to be with his mom. I think she's celebrating a birthday. And so just give us some time to kind of align on this. Yeah.
You
My
work
son
together?
graduated. We were colleagues in applied materials, but right now, both of us are independent consultants, but we are friends now. So we are in the same life situation. So my son graduated last week from high school, and I think he's also did that. So little bit, and then he's doing some travel. So I did talk about him before these big events. But today he's not there, so I'm thinking he's gone to visit his mom in Europe. So I'm not exactly sure about his schedule, but
so you'll talk with him. So you'll talk with him, and then decide what's the
coordinate
schedule.
And yes, something in the works about system level thinking of package, all the different things that can affect, power performance, everything gets affected. It's there is so much of materials related behavior that impacts system performance finally, and power consumption and all of that. So but yeah, so we are going to propose something, but at this time I can't make a commitment because it's just a little bit of a state of flux.
Okay.
So
you'll talk with him and come back.
Yes.
Right.
We are talking, but right now, just maybe in the next few weeks, little bit of, coordination challenge. Yeah.
Okay.
Yeah. So if we can get the other stuff going, this is something, I was talking with him even before I joined this work group, but, now it would be more focused, and the different viewpoints will come together, and hopefully we can make a better integrated system. and
Yes.
present to the community. Yeah.
Okay, great.
All right. Yeah.
So, any other subject? Other than that, we will conclude early today.
Yes,
Sure.
happy to start early.
So this
Okay.
document that you were projecting today, will it be in our? So the wiki, Itai, is all in tip-top shape
Yes.
now.
Not, you know what? Let me share it.
Yeah,
And,
let's take a look, because I
uh,
missed last week because of the graduation. I
okay.
missed last week's meeting. Yeah.
1 second. So, okay, so you see my screen?
Yes.
So this is the wiki page. So I online updated it with this next step of Gilberto.
Yeah.
So I need in the last few weeks I haven't uploaded the recording, so I need to do that.
Okay. Yeah.
Okay.
Great.
Since mid-May I haven't updated, so I think about 3 or 4 meetings to upload here. I'm trying to update to find the documents and point to them. So I'm upgrading here, and so this is the wiki. This is the topics. This is our dashboard for the activity.
Yeah.
Okay. So also I need to update here because I presented last week like an Excel table. So, and also I uploaded it to the.
Can
This
you
is
just
our.
flash it? Just if you can flash what you showed last week, because just chiplet definition. I see.
Yes. So this is our Google Drive. So we have our working document, general OCE presentation, OCE links. So here are documents which we can present on our wiki page. And these are documents that someone present, but he doesn't want to advertise them on the wiki. So this is our folder structure.
Okay, comes to working document presentation.
Yes, and working documents, here you can see first this is the document that Rob started working on, Open Chiplet System Architecture. And this is the document I started, which is an Excel table.
That?
Yes.
Yeah, thank you.
So this is actually started building an Excel table which defines the chiplet. Okay, the system parameters, the phi parameter, the link layer, the test layer. So this is what I got.
Keep growing.
It will keep growing, and this is what I have so far.
Got it.
For example, bow mode. This is from the phi spec. So these are the options we have at the moment. Okay. And what is the control interface? Or this is from for the system aspect. So these are parameters which defines in Rob document. If is it a anchor chiplet? Is it an IO chiplet? More like a system definitions.
Got it.
So the idea here that it will grow. I also, with the intention of making it like a document which maybe then go to like a definition, something executable. I define the parameter kind, whether it's an integer, in enumeration, a boolean, real. So we can.
Got it.
So this is the idea.
And this is something that can all the working group members edit, or we have to send something to you, or how are you doing this? This is all.
Yeah, I think if you want to add, be my guest. Okay.
Okay.
Yeah.
All right.
If you are,
Yeah.
maybe, if let's say that if you want to add another subject, be my guest. If you want to add something to the subject I already started, so let me know and I will add it. Okay.
Got it. Okay.
For example,
okay.
if I guess you want to add a subject of power, right?
Yeah, something, related to or packaging,
Yes, packaging. So go
packaging.
ahead and edit.
Yeah. Okay, but this is where it is our repository for all of that.
Yes.
Yeah. Yeah, it could just be many different things. So, good. And the other ones, so what was the one that you mentioned where you said that if somebody doesn't want to advertise, what does that mean?
So
in the working group?
yes, I think that in some someone presented documents which I'm not sure, I didn't got his permission to show them in our wiki page where they are totally public. So I wanted to present
To at least keep it here. Got
yes.
it. So that we see it.
Yes, we see it, but then it's not. If someone showed this, it's part of this meeting, showed us this, then it's okay to put it here. But I don't want to put
Not
it in the
advertised.
wiki. And the wiki, so it.
Got it.
So that's why I.
So actually, if you don't mind, can you put in the chat the links to this Google Drive? And
Yes.
I think I have the wiki. I may not have this.
One minute. So this is the Google Drive and the wiki page. So here it is.
Oh, the Google Drive. Oh, I thought Anu had done something which was that you really don't need to have a Google account. But right now it's, let me just. Yeah, I did a test for her where I was, yeah, I can get the wiki page, but not the Google Drive because I'm on a
So can you
Hotmail
send
account. Yeah,
Okay.
it should be, but I know, and I did a test actually where any kind of email address should be able to do the Google Drive. So maybe she has to do something special with the Google Drive setting.
If you need to
Yes.
ask for permission, please
Permission. Yeah, I
do
will.
it, and I think some of us get the mail and will grant the permission.
Yes. That should work. Okay, yeah, I do have the, let me just copy the link that way and that should take care of it because I do want to, see whatever documents are being put together and help out on that. So, okay. All right. This looks great. All right. Okay, so I guess we'll speak next week.
Next week, yes.
So I had an unrelated question. Is anybody from the LA area?
I'm not.
Los Angeles?
I'm from Israel.
No.
Okay, far away.
Anyone else? Yeah. No, I'm just curious because I need to make a trip there and things are not looking very good, but I wanted to see if anybody who lives in that area has any kind of experience or anything like that. But that's okay. I know.
I don't live there, but from what I understand, there's specific areas where activities are happening, and if you avoid those areas, you probably wouldn't even know they were happening.
Yeah. That's but the problem is my son has a volleyball tournament this weekend in like downtown LA. So,
Yeah.
that might be challenging. They put curfew and stuff. So I don't know. We'll see. So anyway, such is life.
From where are you, Mark?
Mark,
I'm in Austin, but
Austin.
I'm familiar with the LA area.
I see. Okay.
Yeah.
Blue Cheetah main office is in Austin?
Oh, no. I'm a consultant and I work remotely. Blue Cheetah headquarters is in San Francisco Bay Area.
Oh, okay.
Okay, I'm in San Francisco Bay Area, so yeah, but I have to make this trip, but we'll see what happens. I hope it doesn't get canceled, that's all.
Okay.
All right. Thank you.
Thanks, everyone.
Thank you. Bye.
Yeah, talk to you next week. Yeah, bye.
Bye-bye.
Bye.
Bye.
Bye.